Hi, it's Mr. Baker, and we're going to go over rationals and radicals review worksheet for our end of course test. Very different concepts, but we've tossed them together to help us review. A lot of terms and a few different sets of steps here on this page, as well as a formula or two. So let's take a look at how we're going to use those. What is the value of x squared minus 8x plus 16 over x squared minus 16 when x equals negative 4? Well, we got two good ways to do this one. The first one, we're going to look at this denominator, which is x squared minus 16, and we're going to find our excluded values first. You remember doing that, I hope. Just a little factoring. And x squared minus 16, that's a difference of squares, so we should be able to factor that pretty quickly. What do I square to get x squared? X. Now when we factor difference of squares, everything comes out the same except the signs between them. One's a plus, one's a minus. We call those conjugates. Difference of squares always gives us those conjugate pairs. And then what do we square to get 16? 4 squared is 16, so x plus 4, x minus 4. Well, why is this helpful? Well, it tells us that x can't equal, x plus 4 tells us x can't equal negative 4, x minus 4 tells us x can't equal positive 4, because x is lie. Well, it's wanting us to plug in negative 4, and we just said it can't. And why not? Because with that negative 4, it's going to come out undefined. We know that's an excluded value, so that's going to be undefined. Excluded values are excluded because we don't want it to be undefined. So that's one way to do this problem. Now the other way to do this problem, technique number 2, is just to go ahead and plug it in. I think a lot of people would just go ahead and plug it in. And we do that. Nothing wrong with the top. The bottom comes out 16 minus 16, and 16 minus 16 is 0. Well, 64 over 0, we hopefully remember, we can't divide by 0. And so that right there is a problem, and it means we're going to be undefined. Now, even if you plug this into a calculator, you should still have the same thing happen, but it's going to give you an error. And the reason it gives you an error is because it's undefined, and the calculator doesn't know how to say undefined. So that's two good ways to go through that problem. Defined answer. Number 2, which describes the first and second steps in solving the equation square root of x minus 5 equals 10. Well, probably the easiest way to figure that out is to go through the steps of solving this and then figure out what we did, because we're also supposed to go ahead and find what x equals anyway. And on the first in the first box, we had the steps for solving a radical equation. The first step is to get the radical by itself, that square root. But if we look here, there's nothing else on that same side with it. It's already by itself, so that's not really a step. We didn't have to do that. So the next thing we're supposed to do is we're supposed to square both sides to get rid of the square root. Or if it was a cube root, we would cube both sides. That we do have to do, so that's going to be the first thing. So do that first, square both sides. Well, we've got two answers here, A and B, both say to square each side first. The other two say to add or subtract 5. Those are not what we want. So, so far so good. Number 3, well, let's go ahead and square both sides before we get to step 3. See what's left. Well, when I square the left side, the square root just goes away, and we're left with x minus 5. On the right side, that doesn't go away. 100 squared is, or 10 squared is 100. So x minus 5 equals 100. Well, our third step, now we talk about the third step, we want to solve for x. And x is almost by itself. The only thing we got to do is get rid of that 5. And how are we going to get rid of that 5? Well, since that's x minus 5, we need to add 5 to both sides, which should be our second step. So coming back and looking at these, which one tells me to square each side first, then add 5 to each side? Well, that's going to be A. So we've got the multiple choice part taken care of. Let's just finish solving this. X minus 5 plus 5 gives us just x. 100 plus 5 is 105. So x equals 105, or does it? Remember, we do have the last step for solving a radical equation, which is to check your answers. So how do we check it? We just plug that back in for x and simplify both sides. So that doesn't take very long. 105 minus 5 inside a square root. See if that equals 10. Well, that's going to be square root of 100. Yeah, the square root of 100 does equal 10. It checks out. So x does equal 105. Don't forget to check your answers, because sometimes we get those extraneous solutions with radical equations. Number 3. There's a lot of words here, so let me read this to you. Blah 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 blah. Solve the equation 2 equals 6x over 6 plus x, where x does not equal 6. I think they even wanted to say x does not equal negative 6 there. That may be their typo. I stole this straight from review material. The steps shown appear in the calculation, and that's these steps shown down here. Using the numerals 1 through 4, put the steps in order. So it's another steps problem. Well, again, it's probably going to work best to go ahead and just solve it. Now, I don't have a whole lot of room here, so I'm going to get rid of my blah, 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 because that was all great application stuff, but it didn't really help us solve the problem to know that we were working with a circuit. So we just got the equation 2 equals 6x over x plus 6. Well, we want to get x by itself. We've got both these x's. We got it in the top, we got it in the bottom. That's too many places to have x's. So the first thing I would do is try to get rid of that fraction. And the only thing you can really do to get rid of it is get rid of the denominator. How do I do that? Well, we're going to multiply both sides by x plus, or 6 plus x. That's our first step right there. So when we do that, that's what it looks like. On the right side, they're just going to cancel out. On the left side, we do want to distribute that. And that's our second step, to distribute the term. They're written as 2 times 6 plus x. Ours is written as 6 plus x times 2. Same stuff. Commutative property says we can write either one first, so that's our second step. So let's do it. Distribute that, and that's going to give us 2 times 6 is 12. 2 times x is 2x. Well, now we've got x's on both sides of the equation. Better than being top and bottom. But we don't want to have x's on both sides, so we're going to get rid of one of them. Let's get rid of the 2x, and that's what this step down here says. We want to subtract 2x from both sides of the equation. Subtracting 2x from both sides is going to give us 12 equals 4x. Last thing we need to do to get x by itself, divide both sides by the number that's with it, which is 4. It's pretty obvious that that's our step 4, but because it was the only step left. But when we divide both sides by 4, we get x equals 3. And that's all there is to that problem. The steps really are given to you here. If you look at them carefully, you might realize, hey, it doesn't make sense to divide both sides by 4 in the very beginning. It doesn't make sense to distribute a 2 that doesn't have a place to be distributed. So you can probably follow through and use the process of elimination to figure out what step you need to do each step of the way. It's going to slow you down, but it's better than abandoning the problem. In 1980, James planted a tree that was 1 foot tall. In 1996, that same tree was 71 feet tall. James finds that the height of the tree can be modeled by the radical equation h of t equals the square root of k times t plus 1, where h of t is the height of the tree in feet, t is the number of years since 1980, and k is a specific constant. And that's what we're looking for, is that specific constant k. In other words, we've got an equation. It's right there. And we want to find k So we probably are going to figure out everything else. Plug in the stuff that we do know. So we don't know k, and 1's going to stay 1, so that's what that looks like. And so let's plug in the pieces we do know. We know that t is the number of years since 1980, and we're talking about 1996. So how many years is that? Well, a little subtraction, we get 16 years. That's what we plug in for t. Now, at the same time, in 1996, how tall was the tree? Well, h of t is the height of the tree, and that is 71 feet. So wherever we've got h of t, we're going to put that 71 feet in. It's just about plugging those in and, of course, solving for what's left. So that's our next step, is solve it. Well, we saw the steps earlier. Step 1, get the radical by itself. So here's my radical. I've got this plus 1 with it. It's got to go, so let's subtract 1 from both sides. 70 equals the square root of 16k. Well, now I've got to get rid of the square root. How do I do that? Well, we square both sides. And when we square both sides, the right side, the square and the square root cancel out. The left side, 70 times 70 is 4,900. So 4,900 equals 16k. Divide both sides by 16 to finish getting k by itself. And it comes out 4,900 over 16. That reduces to 1225 over 4. But this one, in the review material, it was actually, I kept it a secret from you, it's actually a multiple choice problem. So it shows me how we want to see these answers written as a decimal, not as a fraction. So we just punch that in the calculator real quickly, and we'll get 306.25. Why did I keep that a secret? Why didn't I show you the multiple choice? I just didn't want you to pick a letter and move on. You can see that there's a fair amount of work that goes into finding this answer. Could you have plugged these in? Well, once you set up the equation, you probably could have, but as long as you've got it set up, you probably find the answer on your own anyway. All right, number 5. Well, we're going to skip number 5. We'll hit it at the end of this because there's actually 3 different ways we can do that one, and I don't back to it. Let's look at number 6. We're not going to abandon that one. We're going to come back. Now, you may have had a printing issue on this one. That should be x to the 4/5. It got cut off at the top a little bit on most people's papers. Hopefully you got it written in. But we're trying to figure out which of these are equivalent to x to the 4/5. And we've talked about equivalent quite a few times. And we said one way to do it is to plug in a number for x. We can plug in 7 for x, use our calculator to figure out what 7 to the 4/5 equals, and then see which of these come out to be that same decimal. Probably not the most efficient way to do it, because hopefully you remember that if we want to rewrite x to the 4/5 as a radical, then that denominator becomes the index of my radical, and that 4 stays an exponent, and that 4 can stay an exponent outside the radical, or it could be, and that was one of our answers right there, is C, just like that. It could also be inside the radical. It doesn't matter. It's going to be equivalent either way. Well, that's also an answer. The 5th root of x to the 4th, that's A. And let's look at these other ones. B has the wrong radical, or has the wrong index on the radical. So does D. And E doesn't have an index on it, which means that's a 2. So none of them have that 5th root there. So only A and C are correct. Number 7. Then we'll still go back to 5. I haven't forgotten. Consider these 2 rational functions. Complete the table by placing a check mark in the box if the x value is part of the domain of the function. Now notice it says part of the domain. I want to know when it is part of the domain. It's kind of the opposite of an excluded value is what it means. But let's make sure we remember, what does what is a domain? Well, the domain, that is just the set of x values that are used in the function. So we want to know which x values are used and put a check there. So to figure that out, it's probably easiest to figure out which x values are not used. Let's find our excluded values. And where do they come from? They come from the denominators. It's whatever makes the denominators 0. So we factor. Let's start with g of x. I think g of x might be a quicker factor because it's, again, a difference of squares. So again, it's going to give us conjugates like we talked about earlier. What do I square to get 9? I square 3, so it's x plus 3 and x minus 3 for that one. Well, that means what are my excluded values? X can't equal. X plus 3 would give me negative 3. X minus 3 gives me positive 3. So what's in the domain of g of x? Everything except for those two. So we leave out the minus 3. We leave out the positive 3. We get checks in negative 2, 0, and 2. Similar idea for f of x. We got to factor this and figure out what makes it 0. So factor that. This time we want two numbers that multiply to be negative 6, add to be 1. That's a positive and a negative. That's going to be a positive 3 and a negative 2. 3 times negative 2 is negative 6. 3 plus negative 2 is positive 1, which means that this time x cannot equal, well, x plus 3 gives me negative 3, x minus 2 gives me positive 2. So again, not the negative 3, not the positive 2, but the domain is going to include the other 3 numbers that were on that list. We got to leave out the ones that were excluded. The way they ask this question, we want the ones that are part of the domain, so we're leaving blank. It's mostly about what's being left blank. All right, so let's come back to number 5. Number 5 is going to be, okay, so we've got an equation here on number 5. We've got 3 over x plus 3 equals 9 over x squared minus 9. We want to know what values of x make that true. In other words, solve this equation. Now, we've learned a few different ways to do this, and there's 3 good ways. There's the easy way, the hard way, and the other way, and which one's which is kind of up to you. So this says click one. On my regular PowerPoint, it's going to give you those options, but we'll just go in order. We're going to start with the cross multiplying. A lot of people look at this and say fraction equals a fraction. I want to cross multiply it, and it's not a bad choice. So let's cross multiply. So we could cross multiply, which means the bottom of each fraction times the top of the other fraction, which leaves me with 3 times x squared minus 9 equals 9 times x plus 3. Well, what's next? We distribute. 3x squared minus 27 equals 9x plus 27. Well, we've got this x squared in the problem. How do you solve an equation with an x squared? Well, we need to get 0 on one side, which means we want to get rid of probably everything on this side over here. Subtract the 9x from both sides and subtract the 27 from both sides. Clears that right side out to be 0. Gives us 3x squared minus 9x minus 54 equals 0. And now what? Well, we're going to factor it. First thing I would do to factor this one, look for that common multiple, or that common factor, excuse me. Greatest common factor, which is a 3. So we pull a 3 out, and leaves us with x squared minus 3x minus 18, still equal to 0. That 3 is not really going to affect our answer, but what the rest of it factors into will. Two numbers that multiply to be negative 18 add to be negative 3. Well, it's going to be negative 6 and positive 3 are those two numbers. Well, what makes each of those chunks equal 0? x's lie, so it's going to be positive 6 and negative 3. But there's something wrong with that. And if you look back up here at the original, especially this left side, although both sides would do it, one of those answers is an excluded value. It can't be negative 3. So that only leaves 6. So let's try our second technique. So we could find, instead of cross multiplying, we could just find a common denominator. And if we use a common denominator, we're going to have to look at what we've got on the bottom. We've got the x plus 3 and the x squared minus 9. X plus 3 is about as far down as it goes, but we can factor that x squared minus 9. It's conjugates again. I think we've seen this one fairly recently. That's going to be a plus and a minus, x plus 3, x minus 3. We should get really good by now with those difference of squares. Well, this has an x plus 3, and that has an x plus 3. So obviously our common denominator has an x plus 3. This one has an x minus 3. This one doesn't. It needs an x minus 3. So we're going to multiply that bottom by x minus 3. And if we multiply the bottom by x minus 3, we multiply the top by x minus 3. Hopefully you had the instinct to say that with me. So that gives us all of that. The good news is we don't even care about the denominator anymore. Once it's common, we don't need to even look at it. That just fades into the background, and our equation is just 3 times x minus 3 equals 9. Like that, and we should be able to solve that pretty quickly. Add 9 to both sides. 3x equals 18. Divide both sides by 3. X equals 6. And that's the answer we had before. So we didn't even find, doing it this way, that extraneous solution that we had to throw out. That's the difference between techniques sometimes. All right, and there is one other technique, and that's the technique of using our graphing calculator to graph both sides. Make y1 equal, there's the calculator. So right here we're going to make y1 equal the left side, 3 over x plus 3. We're going to make y2 equal the right side, 9 over x squared minus 9. If you type it this way, please, please, please make sure you remember your parentheses. And then we graph them. So the first one graphs and looks like that. The second one's going to look like that. And what we really want is to find where they cross. Now, it kind of looks like they cross a few places. Some zooming and stuff is going to help you figure it out. They really only cross in one place. Now, if you really want to be sure, you can always do second calc intersect. We've talked about that before. It'll give us our exact intersection. And in this case, it probably would be helpful because I can't tell if that's going to be in a nice number or a decimal or what. Now, we've seen this a couple times now, but if we're using this to get our answer, we want to zoom in on that and find the intersection, and we'll find that the intersection point is, well, 6, just like it was before. So that's 3 techniques. We could have cross-multiplied, we could have found a common denominator, or we could have graphed both sides to find that one intersection point. And all of them give us 6 as our answer. Remember, if you're using the intersection, we just want that x coordinate, not both of them. And that's it for our rationals and radicals. Hopefully that was helpful, helped remind you how to do some of this stuff. And make sure we get these turned in, staple them all together, and that'll be a quiz grade. It should be an easy 100 quiz grade if you've been following along and taking all the notes.